Have you ever pondered over the intricate workings of the Gaussian filter and the average filter? These two filters are staples in the realm of image processing, each with its unique method and result. The average filter operates by taking each pixel value in an image and replacing it with the average value of its surrounding neighbors. This neighborhood is defined by the filter size, which is usually a square, such as a 3x3 or 5x5 grid. The outcome of this process is a blurred image with a significant reduction in high-frequency components, also known as noise. On the other hand, the Gaussian filter holds a slightly more complex operation. Similar to the average filter, it replaces the pixel value with the mean of its neighbors. However, the Gaussian filter incorporates a twist. It assigns weights to the neighbor's contributions based on the Gaussian function. This means that pixels closer to the center carry a higher weight than those further away. The standard deviation of the Gaussian function, represented by the Greek letter sigma, controls the extent of this smoothing. This results in a more natural-looking and smoother effect compared to the average filter. Now, when it comes to the effects of these filters on images, they differ noticeably. The average filter blurs the image uniformly, treating all pixels equally regardless of their locality. This can result in a loss of edge information and details. Conversely, the Gaussian filter, with its distance considering and weighted approach, can preserve edges better than the average filter while still providing a smooth image. In terms of applications, the average filter, with its straightforward and uniform approach, proves useful for basic noise reduction tasks, particularly when preserving edge sharpness isn't a top priority. The Gaussian filter, with its edge-preserving qualities, is more suitable for tasks where maintaining the structural integrity of the image is pivotal, such as in the pre-processing for edge detection. The mathematical foundation of these filters also differs. The average filter is based on the simple arithmetic mean calculations, which overlook the spatial characteristics of pixels. The Gaussian filter, however, is rooted in the Gaussian function, a key function in statistics used to model distributions and smooth data, taking into account the spatial relationships between pixels. In essence, both the Gaussian filter and the average filter aim to reduce noise and blur images. However, the Gaussian filter does so in a way that better preserves significant structural aspects of the image, like edges and contours, thanks to its weighted approach. The choice between these two filters ultimately depends on the specific needs of your image processing task. So next time you're faced with a choice between these two filters, you'll know exactly which one to pick.